Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, welcome back with me Ahmad Azhari and we are in data communication and computer network class. So before we begin our class, let's start our class by saying Basmalah together. Bismillahirrahmanirrahim. Today we will discuss about the network model. When we take our steps into computer networking science, the first things we learn is usually TCP/IP. Starting from TCP/IP. What is TCP/IP? TCP/IP means Transmission Control Protocol / Internet Protocol. Why? Because both protocols are used as one name because of their function that work together in data communication. TCP/IP can be analog as a language. When humans exchange information, humans will speak a language that can be understood by both speaker and listener. Likewise with computer and host in a network, in order for communication and information exchange to be well established, the same language is needed. TCP/IP is a software on a computer network or networking software contained in the system. TCP/IP used for data communication on the internet or a local area network connected to the internet. Even though the network host brands differ, the host can still communicate with other hosts because they use the same communication, namely TCP/IP. The TCP/IP layers. The TCP/IP protocol suite is a protocol with a hierarchy made of 5 layers. The first one is physical layer, the second one is data link layer, the next one is network layer and transport layer, and the last one is application layer. On this page, we can see the protocols in TCP/IP suite. On the bottom, we can see an IP, Internet Protocol, and the upper of IP will be contain TCP, UDP, ICMP, IGMP, or SPF, RSVP. What is TCP? TCP means a transmission control protocol that contain BGP, FTP, HTTP, SMTP, and Telnet. BGP means Border Gateway Protocol, FTP means File Transfer Protocol, HTTP Hypertext Transfer Protocol, and SMTP is a simple mail transfer protocol. And UDP is a user datagram control, user diagram protocol. Content of SNMP means Simple Network Management Protocol. The other, ICMP, Internet Control Message Protocol, IGMP, Internet Group Management Protocol, OSPF, Open Shortest Path First, and RSVP, Resource Reservation Protocol. And the top one will be MIME, Multi-Purpose Internet Mail Extension. The TCP/IP protocol. The layers on the TCP/IP protocol do not exactly match those in the OSI model. The original TCP/IP protocol suite was defined as having 4 layers. The first one is host to network. The second one is internet, transport, and application. However, when TCP/IP is compared to OSI, we can say that TCP/IP protocol suite is made of 5 layers. The first one, physical, next one is data link, network, transport, and the last one will be application. So we can see on this picture, that the protocols that we have learned before, that we have mentioned before, was contained in the layers. The right side will be the TCP/IP, the left one will be the OSI model. The application will contain SMTP, FTP, HTTP, DNS, SNP, and Telnet. The applications layer on TCP/IP was three layers on OSI model: application, presentation, and session. The transport layer, both same on TCP and OSI, contained of HTTP, TCP, and UDP. On the network layer on OSI model will be IP layers on the TCP/IP that contain of ICMP, IGMP, or ARP, and ARP. And the last one will be data link and physical on OSI model, and host to network on the TCP/IP model, the protocols defined by the underlying networks. So when we got the addressing, there are four levels of addresses are used in internet by employing the TCP/IP protocol. The first one will be physically address, and the logically address, port address, and specific address. When we see okay, when we see the specific address, we'll be employing on application layer. The port addresses will be employing on the transport layer, and the logical address will be employing on the network layer. The physical address will be employing on the data link layer and physical layer. When we talk about ISO and OSI, the background was in the 1980s. The Internet Protocol was first designed in the 1980s. In the 1990s, when the Internet was increasingly popular and hosts were increasing, there were protocols that could only be used by certain groups, or protocols made by certain manufacturers that were not necessarily compatible with other protocols from other manufacturers. So, on this organization, international standard or code by ISO made a standardization protocol which is currently known as the Open System Interconnection Model Protocol, or abbreviated as OSI. This OSI model becomes a reference and the basic concept of theory how protocol and its development TCP/IP as the de facto of the standard. In terms of OSI reference model, TCP/IP protocols include network and transport layer. TCP/IP can be applied to various data link layers, capable of supporting multiple network hardware implementation. On this page, we can see the software outside the operating system will be employing on the application layer. And beside, software inside the operating system will be employing on the transport layer. Only IP address will be employed on IP layer, and the network interface or host to network will be employed the physical address. So here are the examples. In the figure below, a node with the physical address 10 sends a frame to a node with a physical address 87. The two nodes are connected by a link bus topology line. As the figure shows, the computer with the physical 10 is the sender, and the computer with physical address 87 is the receiver. As you can see on this page, on this figure, when we got the 87 as a destination address, so we write on the first column destination address, is right on the first column. We want to send the data to the 87 physical address, this one, and the second column we fill with the source address with the physical address 10. So when we send the data, so it could be contained by destination address and source address with the data as the package would that will be sent into the receiver. On the receiver, there will should be only, there should be same package with the same format. You can see this one. The first column will be same as the destination's address, and the second column will be the source address, and the data package and the trailer one. So the destination address doesn't match, the packet is dropped in the other computers. So the another example in the figure shows a part of internet with the two routers. When we see this one, we got the two routers, the first router and the second router. The two routers connecting to the three LANs, LAN 1, and the LAN 2, LAN 3. The LAN 1 will be connect a computer to the router. LAN 2 will connect between each router, and the router of and the LAN 3 will connect router 2 with the receiver computer. So each device of computer or router has pair of address, logical and physical for each connection. In this case, each computer is connected to only one link, therefore has only one pair addresses. Each computer, however, is connected to the three network, only two are shown in the figure. So each router has three pairs of address, one for each connection. When we see the first computer, the sender one with the source address is 10. You can see this is the source address is 10 and destination address will be 20. So this computer will send to the 20. You can see the address with the physical address 20 was the router 1. So this data will be sent into the router first. So the data will be sent through the LAN 1 to the one link, through the LAN 1, and received into the router 1, by address 20. To another network, the router 1 will continue the data to another router. So the physical address was changed on this part. The source address will be filled by the 1919 as the router source address, and destination will be filled by 33, as the router 2 address. So the data will continue sent from the router 1 into the router 2 by the single link with the LAN 2. And the LAN 2, the same data has received with the source with the same physical address and destination address. So on this router, the physical address also changed by 66 as a as a source address of router 2 and destination address by a receiver address. The data will send from the router 2 into the receiver 95 through the link LAN 3. So in the receiver, the format is also received, with the source address is 66 from the router 2 and the destination address is 95. That was receiver physical address. So this is the example how the data is sent from the sender through the router and received to the receiver. On another example, the figure shows the two computers communicating via the internet. The sending computer is running three processes at this time with the port address A, B, and C. The receiving computer is also running two processes at this time with the port address J and K. Process A in the sending computer needs to communicate with the process G in the receiving computer. Note that although physical address change from the hop to hop, logical and port addresses remain the same from the source into the destination. On the network devices, we also know about the modem. The modem is a device that modulates as digital signals onto analog signal for transmission over telephone lines. And the repeater is regenerates the signal again. So when we see the first picture, the right to left transmission, the regenerated signal and corrupted signal is repeater, which will be repeat or regenerate with the signal again. The corrupted signal is sent to the repeater and regenerates signal with a good condition. And also the left to the right transmission with the corrupted signal is regenerated by employing the repeater and regenerate signal with a good condition. On the other network devices, there is a hub, switch, bridge, routers, gateway, and repeaters. Hub is a function for distributor that has a lot port which connected to computers. Switch like a hub, but it transmits packets to its destinations. A bridge, it is used to connect two similar lines, but routers choose the best path to transmit the packet. The gateway, it is used to connect two different lines and connect different application protocol. Repeaters, as we mentioned before, it regenerates or repeats the signal that travels via long distance. We can see the network devices and the layers on this page. The repeater hub and modem is working on the physical layer. Bridge and switch are working on data link layer. Router and gateway are working on a network layer. Transport gateway and application gateway both working on the transport layer and application layer. Let's discuss about the OSI layer. On the OSI layer, there are 7 layers. Layer 1, 2, and 3 are the network support layer. Deals with the physical aspect of moving data from one device to another device. Layer 5, 6, and 7 are the user support layer, allow the interoperability among unrelated software. Layer 4 ensures that what the lower layer have transmitted is in a form that the upper layers can use. There is one slang sentence that you can use to remember the layers in the OSI model. In Bahasa, you can say A, B, S, T, and G, B. Slang from aku pengen sendiri, tapi nanti ditinggal pergi. So I repeat again. Applications repeat by A, yeah, represented by A. Aku, yeah. P represented by presentation, so with pengen. S sendiri. T tapi, and nanti. D ditinggal, P pergi. So the slang sentence is aku pengen sendiri, tapi nanti ditinggal sendiri. It's the same with the meaning of I want to alone, but they will be left going. Yeah, but I'll be left going. On the Y-side layer, you can see on this 5, 6, 7 or the upper layers, yeah, the applications issues or about the application issues generally implemented in a software or about applications oriented. On the lower layers, there is data transfer issues, layer 1 and 2 about the hardware and software implemented. Layer 3 and 4 are about the software implemented. All the lower layers are network oriented, so you can remember OSI layer are divided by two layers, upper and lower layers. On the OSI layer, you can see the device I and device B are connected to the intermediate node. You can say it was hub, yeah, it was bridge or a modem. So when we see on this picture, all the applications, all the data are transmit from 7 layers to the physical layer. Yeah, so the data sent from the 7 layers into the one layer, the first layer on the physical, and on the physical layer are transmit via intermediate node to the another device on the physical layer 2 up to the 7 layer on applications. Interaction between OSI layers. There are 3 interactions between OSI layers. First is interaction with the layer above or n+1, interaction with the layers below n-1, and interaction with the peer layers in different system or n. You can see on the picture when the application presentation session transport network data link and physical layer or the 7 layers on the OSI models do the interactions. In the OSI terminology, the packet data, also known as the payload, is called PDU or Protocol Data Unit. The packet so form called the Service Data Unit or SDU is passed via service access point to the layer below. This is sent using the service the next lower protocol layer. When the data is sent from one device to another device, the data must travel down through each layer on the sending device, then up through the layers on the receiving end. The diagram illustrates this. Starting at the beginning of the process, the data is handed on application layer. This layer carries out whatever function it needs on the data. Then it hands the data to the presentations layer, which pass it into the next layer and so on down to the physical layer. On reaching the physical layer, the data transmitted on the medium to the receiving device. At the receiving end, the data is picked up from the medium by the physical layer, which hands it over on the layer above. The data travels up through all the layers until it reaches the applications layer on another device. The applications layers then hands the data over the appropriate applications. Now, as the data is passed from layer to the layer, the data is manipulated in different ways. For example, the transport layer segments the data, add the header to the front of each segment. The transport layer always does this to any data it receives from the upper layers. In effect, it is applying a set of rows of data, a set of rows that belong to the layer. The term protocols mean also is a set of rows, and so we will use that word from now on. Each layer has its own protocol or set of rules for how it must handle the data. The 3 lower layers of the OSI model, transport network and data link, all group the data in some way, add the headers and add sometimes the trailers to the head data. A header contains information which is attached to the front of data and the trailer is attached to the tail end. Transport network and data link layers. The transport layer groups the data into the segments. So we say that PDU or primary data unit of the transport layer is the segment. It adds a header to each segment and hands each segment to the network layer. On the right side, on the right picture, you can see that the data on the transport layer, is called the data segment and it adding by the header from the transport layer. All the data, all the segments are added a data header to each segment. So after it sent to the network layer converts it into to a packet yeah, by attaching another header. So it calls a packet by adding a network header. This is a new header. Yeah? This is the last header we adding from the transport, and this is the new one. So it called the packet. So we say that the PDU or the primary data unit of the network layer is the packet. It then hands each packet to the data link layer. On the data link layer, the packet, converts it into a frame by attaching yet another header and also a trailer. So we say that the PDU right now called frame. It then hands its frame to the physical layer. On the physical layer, the frame is converted into a series of bits 1 and 0 and transmit the data onto the medium. So we say that PDU right now code bit or binary digit. This wrapping of data in headers and trailers by various layers is referred to as encapsulations. The whole frame, including the encapsulated packet and encapsulated segment, is shown as below. As we can see on the segment, there are data and the transport layer. Right now, this one, the data and the transport layer header is called the segment. The data added by the network layer header and the transport layer header called the packet. And the packet, when added by the data link layer header and data link layer trailer, called the frame. See, don't forget about the trailer and the header. All both of them is contain the information that was different um, attached to the head of the layer and attached to the end of the data. At the receiving end, the data has to unwrap. The data link removes the first header and trailer from the frame and pass the enclosed packet up to the network layer. This layer strips off the header from the packet and pass the enclosed segment up to the transport layer. The transport layer waits for enough segments to arrive and then assembles the segments together to make the original data stream and pass this up to the higher levels. The unwrapping of data by various layers is referred to as the encapsulations. The physical layer send and receive raw data on the physical media responsible to transmitting the individual bits from one to the next layer. Physical characteristic of interface and media represented a stream of bits 0 and 1. The procedure, the bit coding of transmission, full duplex, half duplex, procedures for starting and stop transmission. The physical layer also detect and report channel status and errors, such as collisions, and all electrical characteristic, voltage level, timing, allowable attenuation are the physical layer characteristic. On the physical layer, the data rate synchronous of bits, lines configuration, physical topology transmission nodes are including on the physical layer. You can see the mechanical characteristic, connector size, and shapes, number of pins cable is on the physical layer. On the data layers, the frames that was wrapped or the data that was wrapped into the frame sent into the transmissions medium and received by another device on the physical layer 2. On the physical layer on another device is unwrapped the data that contain the bits or the binary digits, and on the physical layer all the data is unwrapped into the packet or called the frame. The data link layer. It is functions to determine how the data bits are grouped into a format known as a frame. In addition, at this level, there is error correction, flow control, hardware addressing such as media access control address or MAC address, then determining how network devices such as hubs, bridge, repeaters, and layer 2 switches operate. Dual port 802 specification divides this level into two child levels, namely the LLC and MAC. You can say the data, the frame that contain the trailer and the header on the data is sent from the network layer, to the physical layer and received uh, via transmission medium and received by another device on the physical layer first and the data link layer. And the data link layer unwrap the frame and send it into the network layer. On the network layer, we'll create a header for packets containing IP informations, both the data sending IP and the data destination's IP. Under certain conditions, this layer will also perform routing through internetworking using routers and layer 3 switches. On the network layer is responsible to deliver all individual packets from the original source to the final destinations. Routing is now as functions that route or switch the packet to the final destinations. The segment sent from the transport layer converts into the packet by adding the header of network layer before send it to data link layer. You can see on another device the data link layer will unwrap the packet on the network layers. Also, we can see the data is adding by the header before send it to the above layer. On the transport layer, the data will split into the packets and provide serial numbers to the packet data so that they can be rearranged when they arrive at the destination sites. In addition, at this layer, it will determine the protocol that will be used to transmit data. For example, the TCP protocol. This protocol will send the data packets while ensuring that the packet is received successfully, acknowledgement, and retransmits lost and damaged packets on the way. On the transport layer, from the sessions layer, the data converts into the segments by adding the header on the transport layer before sent to the lower layer onto network layer. On the sessions layer, establish, manage, and decide communication sessions between presentation layer entities. Communication sessions consist of service requests and a service response that occurs between applications located on the different network devices. The sessions layer defines how connections can be made, maintained, and destroyed. In this layer, there are name recognition, NFS, and SMB protocol. On the sessions layer, the data sent from the presentations layer will be packets will be converted and adding the header on the sessions layer before sent to the transport layer and called the segment. On the presentation layer provides coding and conversion functions for data from the applications layer, ensuring that the data originating from the applications layer of a system can be read by the application layer on another system. This layer works by translating the format of data that the applications want to transmit over the network into a format that can be transmitted by network. At this layer, the data will be encrypted or described. You can say that presentation layer, the data sent from the applications layer will be adding the header of the presentation layer before sent to the session layer. On the applications layer, it is the layer where the end user interface interacts with applications that work using network functionality, adjusts how applications work using network resources, and then gives message when an error occurs. Some of the services and protocols that are at this layer, including HTTP, FTP, and SMTP. The applications layer is also responsible for providing services to the user, such as mail services, file transfer, access, and management. You can see on this picture, the user is interaction between the computer and the applications layer through the applications layer. What is contained in each layer you can see on this picture. Layer 1, layer 2, and layer 3. All the network components that contained in each layer is also displayed on this picture. Also on layer 4, layer 5, layer 6, and layer 7, I also added the summary of the network components contained on each layer. The summary, the applications, is used to allow the access to network resources. The presentations to translate, encrypt, and compress the data. The sessions to establish, manage, and terminate sessions. Transport to provide reliable process-to-process message delivery and error recovery. Network to move packets from the source to destination to provide internet working, and the data link to organize bits into frames to provide hop-to-hop delivery. On the physical, the tool transmits bits over the medium to provide mechanical and electrical specifications. This is the last summary. We see on the upper layers, application presentation sessions, all the data displays as a single data form. On the transport layer, the data group and becomes a segment. On the network layer, the data is added by the network header and converts it into the packets. On the data link layer, the data is added by the data link header and data link trailer and converts it into the frames. On the physical layer, on the last layers, on the below layer, the frames converts into the bits contain 0 and 1. Okay, that's all for today. Thanks for watching, and let's close our class by saying Hamdalah together. Alhamdulillahirabbil alamin. See you on the next class, and bye bye.